All right. Hello, everyone, and welcome to join us again for this week's webinar. I have loaded a dataset. You can see it now. I'm going to change the layout so you can see it better in different planes. It's a FIB-SEM data of botanic sample, so we can see it's very noisy, but it's very clear. We have three phases in terms of the intensity, like this. My mouse showing this is the medium intensity, and this is high intensity, and the background is low intensity. So for segmentation, it's quite challenging. For example, if we take a look at the range, which is the thresholding, as we said last time, the threshold will give you a range of the intensity. And now this, I'm using, okay, you can choose the O2. O2 is the method to decide automatically the threshold for two phases. For example, if I use the upper O2, I will, the color now, for the color now, I will get the high intensity phase. If I do the lower O2, I will get the lower intensity phase. You can see either one is not what I want because of the noise. And if I do change the range manually, you can see also for example, if I want to segment the medium phase, I probably have to choose the range to get the medium phase, but it won't work because of the noise and because of the high intensity. You see the interface between the high intensity and the low intensity. The interface is medium intensity. So it's not possible to use the range tool or the thresholding tool on the original dataset to get the perfect segmentation. So the first thing we can think of is to do a filtering. For example, we can smooth or denoise the image. So we can go through that approach and see how it goes. In the image filtering toolset, if I could type my first letter M to, I'm trying to find the medium. Okay, so it should be around here. If I do a median filter, we can see how it goes. I choose 3D dimensional. Let's do a preview. So this is a medium filter applied to the original one. It denoised somehow. So if we apply a higher, a big kernel size, it will smooth further. Okay. You see, by denoising or smoothing, we will get a better image, but we will lose some boundary information because the boundary will be also smoothed. So we can try this first and see if it helps for the noise. So we do medium filter. We applied it. This dataset was cropped from original dataset, so for demo purposes, it would be faster and easy to handle. Now we see a filtered image. If we apply the range, for example, this is the lower intensity phase. I double check. I could add this to new. So I say this is my low intensity phase. And I can manually change my my range to something like this. This will be my medium intensity phase. So I add another one. Oops. I add a new. So this will be my medium And for the rest, I would probably use the high intensity will be this one. So I can use high intensity. Okay, change the color of this to make it more clear. So now you see by using the range or the threshold, I could segment them, choose 3 faces. It's much better than the original one because I denoised the image. It's more smooth now. I have less of impact from the noise. However, we still see a few issues. The main issue is here. You see the high intensity, which is blue, and the low intensity, but because of the interface between the high intensity and the low intensity is in the range of the medium. So you see all the boundary of the high intensity phase has been labeled as the medium intensity phase, which is not correct. To fix this, there are a few method or a few approaches to fix this. One is to use the well, they have some drawbacks too, but we can try it first. First is because the interface is very thin. So if we do a few morphological operations, for example, if we erode, let me erode in 3D. If I erode the medium intensity phase, the RY, so I will, you see here, it removes a lot. So if I do it one more time, I have removed all here. At the same time, the medium phase has also been eroded. So I need to dilate again to make the all the medium phase to go back to the original state. When I do the dilate, I could turn on the range, which means I could dilate the medium phase in the range, so it won't grow out of this range. So let me do one more time. So you see what I dilated the medium phase twice, and you see it go back to the boundary of the original. But for this one, because it doesn't have anything left, well, it still have a few things left. So you see it's not perfect, but it mainly to get the main area of the interface. It removed the interface of the high intensity and low intensity, and I got my medium intensity phase now. So to remove some very small particles or small islands, you can use the islands process. I won't do that again. So this is a basic segmentation we can do with this multi-phase images for three classes or 3-phase segmentation. But I'm going to show something else to do this, because you see still a lot of mistakes, or if we check here, that there's still some small parts in the medium, at the high intensity in the medium intensity. Another approach is we don't use the image filtering. We use machine learning directly on the original image dataset, which is this one. What I'm talking now today is not about deep learning. It's about the traditional machine learning. Okay, so which is from here, you see a machine learning segmentation. I started we can create a new model first. When we create a new model, it's not trained, it's not the, it's okay, it's not the identified, it's unidentified. So this is a new model I just created from scratch. What I need to do is I go to the input tab. I give this as the original data set before the filtering. So I don't need the filtering anymore. So I give the original data set, and also I need to create a multi-LI as the output for my machine learning. Because I already did it before, so it's already here. So I'm going to delete this, what I did before, because I want to show you how to start from the scratch. So now you have no output, which is what I'm going to create now. So I'm create a new multi-LI. So create a multi-LI, and I want 3 classes, like 1 classes for 1 phase. So I need 3 classes. The name is not important, as you wish. I could say my training data or training labels. So I created a multi-LI, which is empty. With what I'm going to do is do some labelings for 1 class. So if I say this is my low intensity class or phase, this is my medium, this is my high intensity. For machine learning, we don't need to label the area fully, which means I don't need a full segmentation of my training area. I only need to label each class a few, like this. This is my low intensity, which I want it to be here. This is my medium intensity. Normally we paint. I'm using my a white brush to paint. I'm going to change the color to make it more clear for you. It's a good practice to paint the boundary, which will tell the program how to handle the boundary pixels. So something like this. So this I give the machine learning tool the model how I should label these 2 phases. And for the high intensity, which is not here, I could go. I need to find my high intensity phase. Where, oh, it's here. So this should be my high intensity one. And the same, this is my medium intensity one. This is my low intensity one. So I need only a few strokes like this. So I just use, now I can choose my output, which is the multi-LI I just painted. It had 3 classes. And now I can choose the method I want to use for this machine learning. We have a few different machine learning algorithms or engines. The very widely used is the random forest, and so I'm going to use this. I will keep everything about the with the default settings, so I don't use the advanced options. For this, it could be a pixel, or region, or majority vote. A difference is if you choose pixel, it will label every pixel individually. And if you use a region, you can compute a region. If, for example, it's by watershed on grid, so you can see it will do some pre-segmentation. You see it pre-segment the faces by watershed, from a seed on a grid. So you see from every seed it will grow to the boundary. So you see them pretty well. You can also change the size of your grid, or of your, like, how you want your grid to be more dense, or which in that case you will use a small spacing. If I use a big spacing, for example, here you will see less seed than big region. Like every region will be much bigger. So it depends on your image features. For this data, I use the 5. So you have every region to be smaller, so you have finer segmentation. And you can also work on the majority vote, which also use the region, but it will classify every pixel in one region and take the majority vote, like how many pixels are labeled to phase 1, how many pixels are labeled to phase 2 or 3. So it will take the majority vote as the class for the whole region. So you can see it very soon. For the dataset, for the machine learning, we have to assign or have to choose the features. This is a major difference between machine learning and deep learning. For deep learning, you don't need to worry about what features to extract from the images. But for machine learning, you have to do it by yourself. Normally, we can do a few. For example, a Sobel filter will provide the boundary information. So I add the Sobel. So which means it will apply the filter to the original images and use the filtered image as the feature for every pixel, because after filtering, every pixel has different intensity. So it will have other information other than the original image intensity. So by applying more filters, for example, the neighbors will provide you can see here, you can provide the information for each pixel about its neighbors. So like how big, you can choose how big the neighborhood is. So it can use the neighbors information, the intensity information, to help classify the pixel, the current pixel. So the same idea, I can add some more, like the self is it self for sure, it's itself. I can add it too. If I do, maybe a moment is about the moment of the pictures. So I have added a few common used features. Now I can do my training. So you see, this is a preview. What do you see is a preview after training. Well, I better use a bigger region to see a better preview. So I do preview on the current region. You see, this is the result of my model. If I hide my training data, it has classified 3 phases, and you can change here to hide them or to highlight them. It gets most of the low intensity and the high intensity. Maybe there's a few mistakes, so we can add more data to correct, to make the model, the machine learning model, to learn more about this. For example, here I don't really want this to be labeled as, it depends. Maybe you want label this area as the medium phase, medium intensity phase. Maybe you don't. It's not very clear for me in this region. But for example, if you don't want this to be labeled as the medium phase, you can correct them by providing more data. For example, I want label this. Give me 1 second. I go back to my training labels. I hide my. You see here, I didn't give the training data. If I want to correct this, okay, I don't want this to be labeled as medium intensity. I want this to be labeled as a low intensity phase. So I do some correction. I can do more, let me go, maybe this is more clear. I want to do a preview here. I show my preview. And I think this is correct. This has been correctly labeled as the medium phase, but this here is not very correct. So maybe here you see that this is a big region, which is not correct. I don't want this to be a big region, so I want them to be, maybe I should use even smaller size for my grid spacing size. Okay, so I got more regions here. Right. Okay. So I want paint because you see here is not correct. I want to paint this as my high intensity. I add this to my training. So I added some more to my training data. So you can see it's a iterative job. So you paint and you get more, you preview, you get more result. And for example, here, if you don't want this to be labeled as low intensity part, you need to label this as medium intensity. The color of the, by the way, the color of the preview is not the same color I painted here, but it doesn't matter. I just want to label this as my medium intensity part. And by, well, we can either either provide more training data for correction, and we also need to see the features. Maybe we need more features, or maybe we need to remove some features which doesn't help. This is the most tricky part for machine learning, most difficult part very often. So you don't really know what feature is more important for this segmentation task. So you have to try. For example, I can add more features. Some of the feature filtering, it gives information about the texture, some about the boundary, the edge. So it could have different effect. Some of them are useful, some of them are not useful even. Make my model worse sometimes. So you see, by retraining with new data, I have get a different result, and I can preview here also. So the good thing about this is it uses a range, as we see the pre-segmented range. So you I'm sorry, the region, the pre-segmented region. So in each region, you get only one label for one region. So you don't get a lot of noise labeled as another phase. So you need to keep verify the model works fine. Sometimes it's difficult to tell. You need some knowledge about your sample and how to label them. Because machine learning and deep learning, both of them depend on how you label the ground truth. So the model is just trying to reproduce the ground truth you have provided. So I could do some correction again here, for example. If I do this, if I train again, should correct this mistakes. So you see here, I just corrected here. Now the new model also made a correction here. so to learn the more features from my new labeling. When you verify everything with the model by preview, you can segment. I won't do this today because it will take a few minutes. So after you click segment, it will apply the model, the machine learning model, or a random forest model to the whole data set. Then you get a full segmentation of the image. You can save the model. In fact, after you quit this, it will be saved. If you close this, the model has been automatically saved here. So if you come next time, it's still here. You can still use this model. You can change the name of the model, of course, if you want, and you can add new data to train it. Oh, it's locked. When you open it, it's locked. So you have to uncheck the lock option. Then you can go to retrain it. With either new dataset, you can have multiple dataset, and yeah, this is for multiple modality. If you have one sample with multiple scans, so you can use multiple dataset as input, and still you have one multi-ROI as the output. I think that's it. That's all I want to share today. In the future webinars, I'm going to show you how to do deep learning, but today it's not about deep learning, it's about machine learning. It's very useful for multi-phase images segmentation. Well, we have some other tools to do multi-phase segmentation, and some other tools to, for example, to compute the for the interface, like the interface area, or to create a interface mesh for visualization. I could share this image data with you for your practice if you want. So now it's time for questions.
Thanks very much, Seshang. There was one question from the audience in the chat box about the data availability. So if you can make that available for testing out this, that would be great.
Yes, for sure. I will send the data download link together with the recording after the session by email.
Okay, great. From my side, thanks a lot. I have to jump off here, but see you next week.
Okay. Bye, Anton. All right, if there's no more question, thank you again for joining us, and I see you next week. So I contact with you by email again. Bye-bye, everyone. Have a good night.